This presentation is about a problem in one-way classification or completely randomized design problem. So we evaluate the difference among the means of three or more groups in one-way classification. For example, number of accidents for first, second and third shift can be put under one-way classification. Another example like expected mileage for 5 brands of tires. So this can also be analyzed in one-way analysis. So what are the assumptions? The samples that are collected from the population are normally distributed and they should have same variance. And samples are randomly collected as well as they are independent. In hypothesis, we put all the means are same, which we call it as a null hypothesis. All the means are equal and then there is no factor effect. In that sense, there is no factor effect. In alternate hypothesis, not all the population will have same mean. At least one population mean is different from the other one. Or in other words, we can say there is a factor effect. So does not mean that all population means are different. There may be one or two pair which will be different in nature. So coming to the hypothesis, if they are not equal, in that case we accept alternative hypothesis. Okay, so when the null hypothesis is true, all the means are same, there is no factor effect, so the curve will be same for all the groups. If alternate hypothesis is going to be accepted, in that case there is a factor effect, maybe curves may not be same for all the groups, so in that case it will be different, like mu1 equal to mu2 not equal to mu3, or the other case B, all the three curve will be different. So coming to the example, there are three main brands of a certain powder and some 110 sample values are examined and they are given in the table. At the 0.05 significance level, is there any difference in a brand preference? So this is what need to be checked. First, we just calculate the values. So the values are given, are listed in the column, and these values are just going to be squared. Just square the columns, each value just square and add the sum. On adding, we get these like summation x1 27, summation x2 32, summation x3 51. Similarly, squared values are summed and they are 305, 294 and 715. After that, we calculate the total sum square and the sum of the squares of a column. Okay. So these are the values. After this, our table. And source of variation, like between samples we are trying, or between columns. So this degree of freedom is number of column minus 1. So we have 3 column, 3 minus 1 is 2. And the sum of a square total that taken from the previous slide, 80.17. To calculate mean sum square, we just divide this SSC divided by number of column minus 1, which is the degree of freedom. So we get 40.08. In the same way, within samples, we have a degree of freedom, total count n minus number of column, which is 9, and the SSE is 225.5. To calculate the mean sum square, divide this SSE with n minus c, and it gives 25.06. So while calculating F ratio, just keep in mind this F should be greater than 1. In that sense, when we put a larger value in the numerator, 40.08 divided by 25.06 in the denominator, we get 1.6 as the ratio value. We just compare this value with the table value, and the table value is 4.26. So the rejection part is this, like at 0.05 level, it's a small portion. As our calculated value is lesser than the table value, the majority of the portion we do not reject, which means we accept null hypothesis. Hence, there is no significant difference in brand preference.